Okay, so this is the last lecture or the last video on confidence intervals. This is where we're looking at applying what we know about confidence intervals and the calculations to particular questions. So I just want to pick up on going through example 1. So a group of scientists, we're looking at sizes of eggs produced by Australia and overseas. So it's measured in terms of its weight, and it's claimed that Australian eggs are smaller than overseas eggs. We've got a standard deviation in the weight of eggs of 5.2 grams. So that's our population standard deviation. And we've calculated a sample size that we need at least 43 eggs. Okay, so now we're moving on. 2 random samples of 100 eggs were taken, one from Australia, one from overseas. Their weights were measured and then stored, and the summary statistics are shown below. So we're given the mean of our sample of 100 eggs. So we've got to show the calculation that would give the 95% confidence interval of the true mean weight of the overseas eggs. So the 95% confidence interval is given by, and it's just simply a matter of using that formula that we established. So that's, we're doing this for overseas eggs, so that's 72.3. So it's x bar, take 1.96 times by the standard deviation, which is 5.2, divided by the square root of 100, and so that's less than or equal to our population mean of weights of eggs. And then it's going to be 72.3 plus 1.96 times 5.2 over square root of 100. So let me just okay, and so that's the calculation that would give the 95% confidence interval of the true mean weight of the overseas eggs. You could initially write the actual formula in terms of x bar, sigma and n. I'll leave that up to you. It depends on how comfortable you're feeling with these sort of calculations. So evaluate this 95% confidence interval. In most cases what I do is I just get out my calculator and plug in those values and find what they come out to. Just for argument's sake, I'm just going to do it to teach you again how to use the calculator. So it's F4 for INTR, F1 for Z, F1 again for 1S, and then because we've already set it to variable, confidence interval of 95, our population standard deviation is 5.2, x bar is 72.3, and n is 100. Okay, and we find that our confidence interval, hence our 95% confidence interval for the true mean population of the weight of overseas eggs is, and that's 71.28 to 73.31. And so to be consistent with SAE standards, I'm going to give that as 71.3. Less than or equal to mu, which is less than or equal to 73.3. So what you're really doing here by writing all this out is you're putting these values here in the context of the question. So you could just throw it down but you're identifying the fact that you know what the question's on about and you know what you're calculating. So it gives you a better, tells the marker that you know what you're talking about. So now we've got to calculate the 95% confidence interval for the true mean weight of the Australian eggs. Again, a calculator exercise. So 70.5, I'll need to remember that. So if we go back to here, standard deviation is the same. Sample size, sorry, I just paused myself there. Sample size is the same. So 70.5 is our mean. So standard deviation is the same, sample size is the same, we just change the mean, we execute, and we get 69.48 and 71.5. So hence our 95% confidence interval for the true mean population of the weight of Australian eggs is, so it was 69.5 is less than or equal to mu, which is less than or equal to 71.5. Okay, so again to 3 significant figures to be consistent with SACE. Okay, so now they want us to comment on whether or not it would be fair for this study to report that the Australian eggs are small in size compared to overseas eggs. So our confidence interval for Australian eggs goes from 69.5 to 71.5. So from about there, and I'm going to make that nice and bold so you can see it. And just to remind ourselves, that's for Australian eggs. Okay. And then the other one is from 71.3 to 73.3, so it's about the same size. And just to remind ourselves, that's the overseas. Okay, so this is our these are our confidence intervals for our mean population of the 2 different eggs, and there's some overlap. So this one starts at about 71.3 and the other one ends at 71.5. So what that means is that the mean of the Australian eggs, the population mean of the Australian eggs, could actually be the same as the mean of the overseas eggs. So the way we write that is, because our confidence intervals overlap, we cannot say there is a difference in the mean weight of overseas and Australian eggs. Perhaps just pop in population, mean weight of the overseas and Australian eggs. I'm really having trouble spelling Australian today, which is not so good. So because the confidence intervals overlap, we can't say there's a difference in the population mean weight of the overseas and Australian eggs, because the Australian eggs might have a population mean of 71.4 and the overseas population mean weight might have a population mean weight of 71.3. So in which case the population mean weight of the overseas eggs is actually less than the population mean weight of the Australian eggs. So we can't say that there's a difference, and so hence it would not be fair for this study to report that Australian eggs are small in size compared to overseas eggs. So you're making a comment about the confidence intervals here, and then you're relating that back to the question and answering the question. Okay. So for the next question, in 1861, Dr. C.R.A. Wunderlich studied the body temperatures of many thousands of healthy people. Body temperatures were measured under standard conditions. He concluded that body temperature was normally distributed with a mean of 37, which we expect, and a standard deviation of 0.5. So in 1992, a study was undertaken. That was actually the year I was born. Wow. Okay. I wonder if I was part of the study. A study was undertaken in which body temperatures of 130 healthy people, I suppose I was a healthy baby, were measured under standard conditions. The sample was found to be 36.8, so a bit on the chilly side. So let mu be the mean body temperature of the population of healthy people, assuming population standard deviation is 0.5. So that's key. That's one of our key bits of information. The other key bit of information is there. The final bit of key information is right there. So n equals 130. X bar equals 36.8. Sorry, just doesn't really want to work for me, but I would put degrees Celsius there if I could, and then the standard deviation is 0.5. Like that. Okay, and so then what I'm going to do to find the confidence interval, so I'm going to say confidence interval, really should put 95% confidence interval for the true mean body temperature is, and then I'm going to go to the calculator and find it out. So again, we're doing 95%, this time it's 0.5, our mean is 36.8, and this time we're sampling 130 people, so I'm going to execute, and that's between 36.7 and 36.9, so I'm going to round that to 3 significant figures. So our 95% confidence interval is 36.7, which is less than or equal to mu, which is less than or equal to 36.9. And I mean, if you wanted to be particular, you could put units on these, but I don't know that that's going to work for me at the moment, so we'll just assume that you've put your units there. So the 95% confidence interval for the true mean body temperature is that. And what I'm going to do is I'm going to finish off this question in the next video.